If we are asked to add a fraction or subtract a fraction where the denominators are different, we need to remember a key point. We can only add and subtract things that are similar, things that are alike. Therefore, we need to make the fractions denominators the same. In order to do that, we say our timetables for both of the fractions denominators, and from there we make equivalent fractions. We'll demonstrate this with an example. Remember, in order to add a fraction with different denominators, what we are trying to do is to ensure that we have fractions which are the same type of fractions. So what we want to do is to ensure that if the denominators are different, which they are in this case, we try to get the denominators to be the same. The way we do that is we say our timetables. So we say our timetables for 5 and 10. So if I write my timetables for 5, 10, 15, 20, etc. I do the same thing for 10, 20, 30, etc. The first number I find in those two timetables will be the number that I will use for my denominator. The first number in both of these timetables is 10. Therefore, my denominator needs to be a 10. Therefore, this fraction needs to turn into something over 10. So I can write this. And then this fraction should be something over 10 also. Remember how we convert our equivalent fractions. If we are doing an equivalent fraction, what we try to do is, remember, if I want to get a 10 down here, I ask myself, what do I multiply 5 by in order to get 10? 5 must be multiplied by 2. Therefore, I multiply the numerator by the same 2. Therefore, my numerator becomes a 4. So 2 over 5 is exactly the same thing as 4 over 10, except that it has a different denominator which allows us to be able to add properly. Same thing happens here. 10 times what gives me 10? 10 times 1. So I multiply the top by the same 1. Now notice I have two fractions now where the bottom numbers or the denominators are the same. Since the denominators are the same, I could go ahead right now and just add my numerators. Therefore, 2 over 5 plus 3 over 10 is 7 over 10. If I am given this fraction to add, these two fractions to add, I recognize the first thing that my denominators are different. My denominators are 6 and a 4. Therefore, I cannot add my problem like this. I need to have a common denominator for both of them. The best way to think about getting your common denominator is to say your timetables for 6. 6, 12, 18, etc. 24, etc. I do the same thing for 4. See my 4 timetables. 4, 8, 12, 16, etc. The first number I recognize that is common to my 2 list is what I'm going to use for my denominator. Notice there's a 12, that's the first number, and a 12, first number that is common to both of this list. So my denominator is supposed to be 12. So I'm going to change each of my fractions to something over 12. So this will represent my first fraction. This will represent my second fraction. Remember how we do our equivalent fractions. I ask myself, what do I have to multiply 6 by in order to get this 12? I need to multiply 6 by 2. Therefore, I multiply my numerator by the same 2. So 1 times 2 gives me 2. Therefore, this fraction now is 2 over 12. So recognize 2 over 12 is the same thing as 1 over 6. It just has a denominator of a 12 now. The same thing happens over here. I ask myself, what do I need to multiply my 4 by in order to get 12? 4 needs to be multiplied by 3 times 3. If I multiply my denominator by 3 to keep my fraction the same, to get my equivalent fraction, I must multiply the numerator by the same 3. Therefore, my 3 over 4 now becomes 9 over 12. Notice my two fractions now have the same denominator. Therefore, I can go ahead and do my addition. 2 plus 9 gives me 11. 11 over 12. Therefore, 1 over 6 plus 3 over 4 is the same thing as 11 over 12. Again, remember what we try to do is get our denominators to be the same by looking at our timetables for 6 and 4 and then using that to create equivalent fractions. Here's another example. We are asked to subtract 7 over 9 minus 1 over 6. We are going to do the same thing. First thing we recognize is our denominators are different. If our denominators are different, our first job would be to say our timetables for 9 and 6 so that we can get a denominator that is equivalent. So what we do, our 9 timetables, 9, 18, 27, etc. Do the same thing for 6. 6, 12, 18. Voila, here's my number. The bottom number, that is the first number that is common to both of my lists, is the 18. Therefore, my denominator needs to be 18. So remember what we do from here. We're going to make our first fraction something over 18. Our second fraction should always be, remember we have minus this time, and our second fraction should be something over 18 also. What do I need to multiply 9 by in order to get 18? I need to multiply 9 by 2. So times 2 here. If I multiply the denominator by 2 to get my 18, then I must multiply the numerator by the same 2. Times 2. Therefore, I have 14 now. The same thing happens here. What do I multiply the 6 by to get 18? I multiply the 6 by 3. Therefore, I multiply the numerator by the same 3. So 1 times 3 gives me 3. Notice again, my fractions have the same denominators. Now I can go ahead and do my operation. 14 minus 3 gives me 11. So my answer is 11 over 18.